The next lesson we're looking at is area of trapezoids, rhombi, and kite. So first of all, when we're talking about trapezoids, we need to make sure that we understand what the height of a trapezoid is. And how you determine the height is that you need to look for the two parallel bases. So once you know what the two parallel bases, the height will be the segment that connects the two bases at a right angle. So again, it is not the slants on the side. It could be if the sides are perpendicular to it, but if it's not, you need to make sure you find the height, which will be perpendicular to both of the bases. That's the height of the trapezoid. So to figure out the area of the trapezoid, what you're doing is that you're going to add your two bases up, B1 plus B2, and you'll divide it by 2, and that will be kind of like the average of your two bases, and you multiply it by the height. So that's the area of a trapezoid. So looking at this trapezoid down here, first of all, we need to make sure we know the two base sides. So here's our two bases because those are two sides that are parallel. And then we need to figure out what the height is that connects them. So this is 1. So then we fill in our formula. Base 1 is 3. Base 2 is 2.5. We'll divide that by 2 and multiply that by 1 for the height of the trapezoid. So height of a trapezoid is equal to your two bases. You add your two bases up, you divide it by 2, and then you multiply it by the height. And so for this trapezoid, it'll give us an area of 2.75 centimeters square. Area units are always square. Next, we have this trapezoid for a pool. And again, we need to identify our two bases, 30 and 25. So 30 plus 25 divided by 2, because it's the two bases. You add them up and you divide by 2. And then we multiply that by the height. The height is always the segment that makes a right angle with both of the bases. So in this instance, 11. And that gives us an area of 302.5 square feet. Looking down here at this one, I see a base of 9. And here's my other base, but I don't have a length. I have a height of 4, because that is what makes the right angles with both bases. And so in order to find the length of the other base, I look over here at the side and I see a right triangle. My right triangle I'm looking at, I can do the Pythagorean theorem to find the third side, or I know it's a 3, 4, 5 right triangle because my 5 is on the hypotenuse and my 4 is on one of the legs. And so with that, I can tell that 9 minus 3 is 6. So that's my other base. So to find the area now, I need to take 9 plus 6 divided by 2, because it's B1 plus B2 divided by 2, base 1 and base 2, and multiplied by that by the height of 4. That'll give me the area of this trapezoid, which is an area of 30 square feet. Now let's look at the equation for the area of a rhombi and a kite. So rhombi and kites have diagonals that we're going to deal with. So, and remember, these diagonals are always perpendicular to each other. Diagonals connect from the vertice to vertice. So the area of a rhombi and kite is the equation 1/2 d1 times d2. So we have to take our two diagonals and multiply them, and then divide that by 2, and that gives us the area of a kite or a rhombi. So looking at this kite, I know my two diagonals are 7 and 12, and so I just fill it in. Make sure you multiply these. So in a trapezoid, we add our two bases, but in a kite, we multiply our two diagonals. That gives us an area of 42 square feet. So looking at this rhombi right here, what I notice is that it's only part of the length. So the whole length here, 7 plus 7, which is 14. And then the other diagonal will be 9 plus 9, which is 18. So maybe I need to write it over here. I kind of ran into the 7. So this is the whole diagonal here is 18. So remember the equation of a rhombi. It's 1/2 diagonal 1, which is 14, times diagonal 2, which is 18. And this will give me an area of 126 square inches. Looking at this kite, I know it's 1/2 D1, which is 9, times D2, which is 13. This gives me an area of 58.5 square feet. Sometimes we know pieces and we need to find the missing pieces given the area. And so this time I have given the area of 20. So area is equal to, and this is a trapezoid. We want to find the height. Remember the height is the right angle that connects the two bases. So I need to say 7 plus 3 divided by 2 times the height. Because the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. This will be at 20 equals 7 plus 3 is 10. So 20 equals 5h. So divide both sides by 5, and the height is equal to 4. That's how you would solve this one. The next one, you need to find this missing diagonal. The area is 25. So remember, area is equal to 1/2 D1 times D2. I know one of my diagonals is 5, but I don't know what the other diagonal is. So I'm going to take half of 5. So 25 is equal to 2.5 D2, and then divide by 2.5. So divided by 2.5, I get that my second diagonal is equal to 10. Here's another one where we want to find the height. So this one, always identify the shape first. It's a trapezoid. Once you know the shape, pick out the right area formula. So it's half of B1 plus B2 times the height. Our two bases are 20 and 50. So that's half of 70 times the height is equal to 210. So half of 70 is 35. Once I divide both sides by 35, I get my height is equal to 6 yards. This is just a recap of the formulas that we have gone over in the last two lessons. We have our parallelograms, which includes rectangles and squares in any parallelogram. The area is equal to base times height. Triangles, area is equal to 1/2 base times height. Trapezoid, 1/2 B1 plus B2 times h. I just put the h at the back. And then Rhombine kites, Rhombine kites are 1/2 diagonal 1 times diagonal 2.